My name is Fieldraccoon, and I'm going to be doing a talk on how to approach boot-to-root machines for beginners. And I'm going to say a thank you to Omicron for allowing me to present this. If it wasn't for them, then I wouldn't be here. Okay, so who is this talk for? This talk is going to be for beginners who are looking to get into their first machines, either on Hack the Box or Try Hack Me, or people just wondering how to solve these types of problems. It's really easy to get overwhelmed by not knowing how to do these things or not knowing where to learn them from. But I'll go over everything, so it's okay. If you're not a beginner, I'm still sure you'll be able to pick up loads of things from this. What is a boot to root machine? A boot to root machine is basically a virtual machine designed with certain vulnerabilities in order to be exploited in a certain way. The end goal is to gain a root shell or an administrator shell if you're on Windows. Each boot to root machine will often teach you something new and provides a new learning experience. They can be any type of operating system, but it's usually Linux or Windows. You sometimes get other operating systems such as FreeBDS on Hack the Box, but you don't really get many other ones. Where can you practice? There's loads out there, but the main ones are Hack the Box, Try Hack Me, and VulnHub. I prefer Hack the Box because it feels like there's a much more range and a nicer community, but Try Hack Me has a lot of good stuff if you're learning to set a certain skill. So what is the main goal? So just like in CTFs, if any of you have played them, the main goal is to get a flag, essentially. But in boot to root machines, you often get two flags, a user flag and a root flag, which you have to be root for, and obviously for a user flag, you have to be that user for. All you get given at the start is an IP address, and you have to hack your way in to the machine and make yourself that user or make yourself that root, usually through a shell. But sometimes there's flags where you can just read them through like a file inclusion or something. It's often quite daunting if you don't know where to start. I know I didn't really know where to start when I started, but I've learned a lot in the process from other people, from Discord, and from Google. But don't worry, because I'll explain the process. So what happens in a boot to root machine? Basically, there's a set amount of stages, but this is just the main stages. Some machines might have more, some machines might have less, but this is the standard structure for them. You'll always have reconnaissance and your enumeration. This basically allows you to find out what the box is about and what you're going to be attacking. You also have threat modeling and vulnerability identification. This usually comes after your enumeration when you're trying to figure out what to do with a machine and how to exploit it. Of course, after that comes the actual exploitation. This can be with anything. It's usually, yeah, it can be absolutely anything, whether it's Metasploit or a command injection or an SQL injection. It's basically anything. Some machines also have where you need to patch them. So in King of the Hill from Try Hack Me or Hacking Battlegrounds from Hack the Box, you'll pwn the machine and then you'll have to fix your vulnerabilities so the next player can't get in the box even. So what happens in the enumeration phase? So the enumeration phase is basically where we just put loads of scans on the box and try and figure out what the box is about. Without enumeration, you wouldn't be able to do anything because you wouldn't know what was running. So you always start off with an Mmap scan. I think there is other things out there such as mass scan or rust scan. It allows you to discover key points about the machine, tells you what ports are open, what versions of those are open, also tells you what you're up against and what you'll be exploiting. If there's a port 80 or 8000 or 443 or any other ports running on HTTP, then we can enumerate this using web tools such as GoBuster, which scans for directories, or if you put it in virtual host mode, it can scan for virtual hosts. We can also use Nikto to identify common vulnerabilities for us. So when you run that, it'll scan for a little while, and if it notices any important or interesting redirects in the URL, it might tell us something interesting about the box. There's loads of ports on machines, so some might have certain open, some might have others. It completely depends what the author has decided to make the box for. So if port 445 is open for SMB, then you could use SMB client or SMB map to enumerate the shares. Likewise, if port 21 is open, then we can access the FTP server and see if there's anything interesting on it. So you just log in, list files. If there's anything there, then hooray. If they're not, then oh well. These are just examples. There's endless possibilities out there that the author might set up. The main thing we do is after our mmap, see what's available and go from there. If you don't know how to do it, then Google it. If you don't know what a certain port is, then Google it. Research is basically the only way you get through this, as every box is different. The skills apply on each box, but they're mainly different. So, what happens in the vulnerability identification phase? This comes after your enumeration, after you've seen what's on the box and etc. So if a website is running a certain service, such as Apache Tomcat, I know that has some Metasploit exploits. Metasploit might have an option for it, so you could just search that for Metasploit and hope it has it. If there's some interesting redirects in the URL, such as $file equals, you could be able to exploit that via LFI. If it's vulnerable, it's always worth a try. That's often a common one in CTFs. If the server is executing your code, maybe by a login form or a login box, then you could try SQL injection or command injection. If it's none of those, it might have a certain service, and just Googling that with the key terms CVE or exploit might come up with an interesting proof of concept. A lot of the time on GitHub, it's the biggest place for people to share their code, so why wouldn't they use it? And a lot of the time on hard boxes, maybe there'll be a proof of concept on GitHub, and you'll use that and you'll tweak it slightly, and you'll make that into your own exploit. The possibilities are endless, as I said. There's so many different things out there, and there's always new ones coming. Basically, what you do is you just see what you have, you Google what you have, and you do something with the Google results you found. And then comes the exploitation stage. So most of this has already been at this point, after you've identified what the exploit is, you've probably already thought about how you're going to exploit it. And at this point, you just exploit it. You might be leaking a password with SQL injection, or you might be getting code code execution through command injection, or yeah. Common ways of exploiting can be, Metasploit, binary exploitation, SQL injection, pretty much anything, as long as you're actually just exploiting it. Then comes privilege escalation as well. Most boot-to-root machines need some sort of privilege escalation, Linux and Windows alike. It's where you use your existing presence as one user and attempt to gain access as another user. This is often from user A to root, but sometimes there's, user A to user B and then from them to root. In Linux, often in the more simple boxes, easy and medium, there'll be some kind of cron job or an interesting binary, a lot of the time custom, sometimes known binaries, which can be used to get a shell. A lot of the times, a simple sudo-l command will get you the things you can run as sudo, meaning those commands are being executed as root. So if root is executing a command, then if you run it as root, then you are essentially root. So you can use that to try and read the root flag or get a root shell. At the harder levels, they will be a lot more obscure, as a simple echoing a reverse shell to a cron job file that's being executed as root isn't really realistic. So in the real world, that's not going to happen because that will have already been patched. They're only supposed to teach you the fundamentals, so that when you approach a course such as uh, certified penetration tester or certified ethical hacker, then you have a very good idea of what happens. So we're going to be doing a live demo, and we're going to be doing a machine from Hack the Box called DevOps. It's a medium Linux machine, but I think it teaches the fundamentals really, really well. By that I mean all the different stages, enumeration. It's got some privesc in there as well. It's got everything. It does have enumeration, and then you find a web server. You then find an exploit. We then construct a payload and use Burp Suite to help us analyze the responses and read an SSH key. After getting the SSH key, we log in and then we enumerate further as the user on our shell and find a Git repository, which we can then exploit and get a shell, get the root SSH key, and then get another SSH key session. So here I'm just using my Kali Linux, which is the virtual environment that I use to perform pen tests on Hack the Box or anything else. So the first thing we do is we grab the IP address from our Hack the Box machine, which for DevOps is 10.10.10.91. So we ping that to start off with to see if we have a connection. We can see here it's pinging it. So it's pinging it with 64 bytes, so we know we have a connection. If it doesn't ping, then we don't have a connection and we can't do anything on it. So first of all, like I said on my previous slide, we're going to start off with an mmap scan. So we're going to do mmap-sc-sv. This enumerates the versions. And we're going to output this to a file called nmap so that we can look at it later. We're going to let this run for a second. And we can see that it's finished the scan. Did this quite quickly. There's clearly not much on it. So SSH is open, which is just a means of connecting to the box. We also see that port 5000 is open on HTTP. It's running some sort of service called Goonicorn. Not sure what that is. It's not really needed though. So as we said on our previous slides, if HTTP is open, then obviously we can go check that out. So we can do HTTP the IP address 10.10.10.91, and then we have to put the port 5000. If we just put that, it wouldn't work. Even HTTP, it doesn't default to the standard ones if it's not running on them. So we're met with a quite a static site. We've got an image and we've got some notes saying to do replace this with the proper feed from the dev.solita.5 backend. This part is quite irrelevant. You don't really need it. Yeah, yeah. It seems to be running Flask. So we don't really have anything off the bat. We can view source, but this isn't really a CTFE challenge, so it's probably not going to have anything in source code. So we're gonna head up a GoBuster scan to search for directories. So we can do GoBuster -u dir to put it in directory mode. -u to specify the URL, and then we put our port in there, and then -w to specify the word lists. For most people out there, it's going to be in user share word lists dir buster direct, and the one I like to use is called directory list23medium.txt. We're also going to output this to a file called dirs, so we can come back to it later if we want to. I like to use that word list because I generally have the most success with it. We can see it's already got a few hits. We've got feed and upload, so we can go have a look at those. We can go feed. I think that's just the image that we've had before. Instead, we can go to upload, have a look at that, and we see that there's some sort of upload file. So we can see that it seems to be for XML files, and it needs the elements author, subject, and content. So if we just make an empty XML file called file.xml and upload that, we can see that it hasn't. We get an internal server error. So if we open this in Burp Suite, I use an extension called Foxy Proxy, which switches my proxy to localhost, so I can use Burp Suite with it really easily. Intercept is on, so we upload that, and we'll send this to Repeater to analyze it a bit more. If we send that, we get an internal server error. I think this is because we haven't met the requirements it needs, author, subject, and content. So we'll leave that for now. We'll drop the request and we'll come back to this. So what will our standard XML query look like? So most XML queries will look like this. So we'll have our things that it needs. So we'll have author. They look like standard HTML, if you know what that is, which is a code used for coding websites. So we'll have that. We'll say my author is Fieldraccoon, and then we'll put a closing tag called author. So that's our author tag. What else do we need? We need a subject and a content. So we can do subject, our subject here, and we close the tag off. And then we can do a content tag as well. Our content here. Content. Okay, so that's good. I'll just get rid of the spaces at the start. I don't really like having them there. And if we uploaded this, I think you'd find that would be alright. So if we did test.xml, we pasted that in. I'll make sure I've spelled everything right. Author, yeah, looks good. So if we then turn the proxy back on, test.xml, upload, and enter a pizza, and we get another server error. What have I done wrong? Oh yeah, so we're getting internal server error because it's not processing them directly. We're going to need to add something to it. So we're going to need to wrap this all in another tag. Some people call it entry. I like to call it entry. It can be anything. So I'm just going to say wrap this in a tag called field. So if we send, oh fuck off, why is it? Subject I've spelled that wrong. Content. No. I'm just going to copy the correct code, put that in. I'm not sure why this isn't working. Get rid of that. Okay, it looks like it's being a little buggy, so I'm going to turn this off. I'm going to reset the box, and we're going to come back in 2 minutes. Okay, sorry about that. I remember when I actually did this machine in the first place. I remember sometimes it was quite buggy. Might just be me. Um, yeah, so let's try this all again. Let's head back over. I've actually copied over my correct code um, that we can try. So um, it should look like this. Subject. If this doesn't work, then I might have to redo the talk and try and do something with it. So we're going to go back over to the browser and field.xml, and we're going to turn burp back on, and we're going to intercept this again. Okay, burp isn't on. Um, on upload, and then we'll wrap this in tags. Send, and we get a 301. We should be getting a 200. Oh, follow redirect, and we get a 200. So it's worked, which is what we want. So we're gonna turn it off. We're gonna turn burp off, and we know it works because we got a 200. So we're gonna vim field.xml, and we're going to add our item tags around it. You can call this anything. I'm just calling it item. Item. And if we cat that, then we can see what it looks like. So if we re-upload that and intercept it with burp, then why is I'm not sure why it's done this. If we change the name, okay, we'll just drop the request, um, and then try to do that again. Appreciate this isn't the most entertaining thing ever. Oh, I don't have burp turned on. Oh, I'm stupid. I missed the closing bracket. Yeah, so make sure to go over it. Sorry about that. So now we can now we can see it's processed it. So it's telling us the author is Fieldraccoon, our subject here, just like there, our content here, just like there, and it's referenced our URL. So if we head over to uploads had.xml in the URL, it will show our file. It also tells us the file path, so we can see that it's in home, and it's in a user called Ruser home directory. So we instantly think this is going to be the user for the box. We can see that it's stored in deploy and then source. So if we tried changing this, so I'll head back over to here and I'll just add our closing tag real quick. So now if we stop that, we turn burp off, and we turn intercept off, we can go look for exploits. So we know that it's an XML file upload. So then we can say exploit. So we see everywhere that it says XXE. XXE is just basically an XML entity exploit. So if we search XXE file upload exploit, for example, and let's just try file read, because we know that it's in home browser. So what we think here is if we can grab her SSH key, if we can get a file read. so then we can log in as her. So we tried Googling about this, and yeah, we'll try XXX injection file read. So we find a few different websites. I'll open that on a new tab so I can come back to this. We'll open this one as well. So this is us researching how to do what we want to do. We want to read a file, now we need to figure out how to do it. So we can see this here, it sort of uses an entity and it reads a file called application.conf. We can carry on going down, we can see that it uses the same tags as what we've had. We can see this here, we might need this for later on, where we declare our call here, so our file read, and then we use this and ampersand file to call that. So maybe we can use that within our own tags. Not much here. We'll go on to the next one. My VM's lagging a lot. Bear with me. Okay, we look good now. So we're on this website. So let's have a look at this. So an entity example. So we see it's declaring something here and it's calling it within our tags. That looks quite useful. Local file inclusion example. So if we take this and we copy it into a text file, take that and we copy it in here. Did it not copy it? Copy. Repeat. So let's put this on its own line over here. So we can see here that these normal foo tags look like our tags in here, our content, subject, and author tags. And we see here that it's reading etc past wd, which just stores all the hashes for users. We can see that it's calling this and calling it here. So if we try modifying this for our own, so if we do take our old one, so field, and then close it off down here, and we've got our author, our content, and our subject, and we need that so it doesn't we don't get an error, internal error. So then we can paste this above it, and we can try and make this nice. So we're going to remove the brackets from here. I think there was some sort of filtering on it. It doesn't work if we put the brackets in the hash without it. So we're just going to keep it like that. We need to put this on the new line as well. So this is our place where we're going to read the file, but we're going to need to call this. So we've called the entity xxe, and then we refer back to our own entity in here. So we've replaced the author with ampersand xxe that, which is calling this. It should trigger our file read. So we'll save this. Actually, no, we won't save it. We'll just copy and paste. Save as, go away. So we'll go back to our feed. We'll put Burp Suite back on. Turn that on. Upload. Send to repeater. Okay, and we're gonna edit this. So we're gonna add our all this. I'll just keep the item tags in case it bugs out. So then I'll get rid of this and put item down here. Okay, so this should be good. So if we send that, we get an internal server error. You'd love to see it. Oh, yeah. If we try putting that over there, item. If we just drop the request, we'll try this again. upload that. Okay, so we can see that throws a 200. So if we upload that again, not sequencer, repeater, and we send that, it throws a 200. So then we put in this. And then we throw in our this here. And we see it works. So we get 200 and it reads Etsy password. So let's try changing our file. So we know that it starts at home. It goes into Ruser. It goes into .ssh, which is the default SSH folder. And most SSH private keys are called IDRSA, presuming they haven't changed them. And here we get a SSH private key, which is lovely. So we'll copy this. We'll make our own file called IDRSA. We'll copy this in, and then we'll exit. We'll chmod 600 and change the permissions of this, because sometimes it doesn't allow us in if we've copied the private key straight from it. So then we can SSH, use the -i parameter for our own SSH private key, and then we go Ruser 10.10.91, which is our IP. It's loading it, and you can see that we've just logged in with SSH. So we can see here, and we can cat the use. We can we can we can cat the user.txt. So we can see there that that's our hash. So we can look around now. So we've submitted our user flag and we're happy. So now what we want to do is we want to try and get a root. So we can try enumerating. So we can cat this blog feed thing. We can see that it's going into blog feed, work blog feed. So we can have a look at that. And run as blog feed user, which is restricted. So it clearly doesn't want us to be in there. So we can go into work. We can go into blog feed. And we can go into source as well, but we probably want to go back now. We can cat index.html and we can see that that's our feed website. So we can cat readme if we want. At this point, we're just enumerating the box further because we want to try and look for a privilege escalation route. So we ls-a to see if there's anything interesting files, and we see a .git. So the name of the box sort of clicks here. This person's developer and they're using GitHub to manage their code. So we're going to go into the .git file, and then there's all the default Git files in there and configurations. So as soon as we do Git, we can Google like how to use Git command line to reveal commits, for example, because we believe if there's a Git directory, they might have created an interesting commit. So we can do view, we can look around, we can Google at this point. So it says here we can use something called git log. So if we do git log, and we can see there's a bunch of commits. So this one looks normal, this one looks normal, some security. They're installing their initial app version, they've added a startup script. What it does look interesting is this, reverted accidental commit with proper key. So we can Google how to show this commit, but I already know how, so we'll copy the commit link. Or we can do something called git show and then the commit. So here we can see that it's revealed some sort of key. So the red means that it's deleted it, and the green means that it's added it. So we can copy this, and this is actually the private SSH key for our root user actually. So if we vam root RSA, and we need to fix the formatting for this. So we remove all dashes, and we'll add the 1, 2, 3, 4, 5 begin RSA private key. This is the standard format for keys that we need, and then we'll chmod 600 root RSA. So it says here something about resources, integration, auth credentials key. So if we go back for this and we go back a few, we're going to work, we're going to blog feed, and then we go into resources. We can see there's a folder called integration and cat auth credentials.key. So this seems to look like the private key it just seems to be a private key. So they've just changed it. They used to have something like this and they've changed it. So we can see this root private key. So let's try to log in as root ssh-i list our file, which is root RSA, and then we can log in as the user root. Let's see if this works. Let's go back. Let's gmail 600 it again. Hasn't worked. Maybe we've screwed something up. So we'll copy this again. We might have accidentally done something. Might have deleted a character. So do this slightly slower. Okay. And then we'll just copy this file, this line as well. Okay. And then this last bit should be 1, 2, 3, 4, 5. Let's just copy this actually. Copy. And we'll just change that with end gmod 6. And it's worked this time. I'm not sure what wrong. Maybe we accidentally deleted something. And we can cat root.txt. So that's our box rooted. I hope I explained well the different stages. So we went through enumeration to find the upload. We researched using Google about XML file uploads. We then read a proof of concept on the website using this, and we swapped our call function with our own tags. We then uploaded this. We learned a little bit how to use Burp Suite and how we send a repeater, change the request, and analyze the response. And then we got the SSH key, and then we logged in as user. We then enumerated files. In this case, it was Git directories using the Git command line utility. We then found this commit where they somehow deleted something. They deleted their proper key. They've deleted this, so then we can bring it back with git show, and then we've copied it and we've logged in as root. Thanks for listening. I hope you enjoyed. I hope you learned something. And yeah, so bye for now. Thank you.